My name is Brandon Saunders. I'm a GIS specialist with Highland Mapping. Been there a little over 3 years. This is my third time at this conference, twice with Highland Mapping and once back when I was an undergrad. Highland Mapping as a business, I think this is our 11th time here, so we've been around quite a while. I'm sure most of you are familiar with us. For those that aren't, we're a GIS consulting company based out of Banner Elk, North Carolina, up in the mountains. We specialize mostly with municipal county governments. We do a lot of database implementation, integration, development, that kind of thing. Also roll out some mobile apps, and we do some web design, but really the backbone of our business is database consulting, database development. We work a lot with making different databases communicate with each other, CAMA data, CAD data, other databases. And that's really what the bulk of this presentation will be about. So the dashboard itself is kind of the culmination of it, but most of the presentation will be about the data processing that went into actually making the dashboard usable. So to just kind of give you an idea about what we'll go over in this presentation, we'll start with a overview of the project itself and the client, some of their IT infrastructure and how that influenced some of our decision making. We'll go over the data processing, importing it into SQL, some additional data processing we did once it was there, and then I might do a demo of the dashboard kind of depending on time and whether I can get it to show up on that screen. So this project was for the Leland Fire Department. We've been working with the town of Leland for several years, like I said earlier, doing mostly database development, managing their SDE, bringing in their CAMA data, all that sort of stuff. Kent was down talking to Leland about a year and a half ago, and he met their fire chief, who expressed a real strong interest in being able to view his data in GIS, but had no GIS experience, so he didn't know how to do it. He was very busy, so he didn't have time to learn. But he had seen an operations dashboard presentation at another conference, and he liked what he saw, primarily because I think a dashboard is a real intuitive way of displaying spatial information, especially for people that have no GIS experience. So I'm sure by this point, most of you have seen a dashboard. But for if you're ever trying to convey information to somebody that's not real familiar with GIS, I think a dashboard's a great way to go because it's real intuitive. So to give you a little bit of background on the town of Leland itself, it's located down near Wilmington, just across the Cape Fear River. It's still in Brunswick County, and it's been growing really, really quickly for the last 20 years. So between 2000 and 2010, population went from about 2,000 to 13,500. And then since 2010, it's grown an additional 40+%, and right now they're around 19,000 people. So in less than 20 years, they went from less than 2,000 to almost 20,000. So as a result of that, their fire incident call volume has gone way up. It more than doubled in a 5-year period. And as a consequence of all that growth, their fire department is now a fully funded division within the town. And that happened in 2017. So prior to 2017, they were completely volunteer-based. And so that's part of the reason he's gaining interest in this, is now they're funded. He wants to work toward accreditation. And part of that process is a self-assessment where you collect a lot of data about the department, how long it takes you to get to calls, all that kind of stuff. So that's part of what we're helping them do, is to accumulate a lot of data about themselves and help them work toward accreditation. Go over a little bit about their IT infrastructure because it did influence some of the decisions we made. So their entire network is a fully hosted environment. So I'm not specifically referring to GIS services in this context, but everything is hosted. So we work with a third-party vendor to gain access to their servers and all that kind of stuff. They do have an ELA with Esri. Full-blown enterprise GIS environment is in place. At the time of this project, it was at 10.3.1. There are plans to upgrade it, but there's some third-party stuff that's kind of holding us back a little bit. Since they have an ELA, they did have an ArcGIS online organization available, but nobody had been using it. So that was also part of this project, was to help them get their organization off the ground. And then the last little bit in reference to their IT infrastructure is that they've been a long-time client of emergency reporting. And that was important for this project because it sort of sits in between their CAD data and GIS. So they were in the process of switching CAD vendors. They've been a client of Southern Software for years. They were switching over to a company called Zerker. And when we were designing this project and coming up with the workflow, we didn't want to come in and spend all this time and set this up to then come back 6 months later or a year later when they switch CAD vendors and then have to redo it. If the field names change, if the data schema change, and that sort of stuff. So they are going to keep emergency reporting even when they switch CAD vendors. So since the data schema would stay the same, we decided to go with some of the custom reports that are available in the emergency reporting interface. So that's what this is. This is an example of a report I ran for the first half of 2018. And what I want to draw your attention to in this slide is the formatting. Because if you download the Excel spreadsheet that they make available, you get something that looks identical to what you see on the screen. And while that's visually attractive and it's good for presentations and stuff, it's not really tabular data. So if you try to bring that into Arc, it's a mess. It doesn't work. So we decided to go with the text download route, and that will give you a CSV file. And so that's what this is. This is the CSV just opened up in Notepad. Just to highlight some of the things that jumped out to me right away. There's some header information that we didn't need, the field names we didn't need. And then if you look at that highlighted portion in blue right there, that is supposed to be one incident. And if you look, you can tell that each incident is being split right after the zip code, and it's being pushed down to a new row. And that's something we're going to come back to a couple times over and over again over the next few slides, because that was really the formatting issue that we ran into that we had to resolve. So as far as what the fields are, we've got incident date, incident type, we got location information there all in one field. That's the full address field that's got quotes around it, so that's the text qualifier. That should all come in one field. And then we got a series of time fields. So this is that same CSV opened up directly in Excel. And as you can see, we're running into that same issue where after the zip code, everything that comes after that in the row is being pushed down to another row. This is what it looked like when we brought it directly into SQL. And the full address column there actually looks pretty good. We would have to separate out those values, but that's doable. The other issue, though, was that all the time fields came across in one field. And so we would have had to split them up too. And one final example, this is what it looked like when we tried to bring it into LibreOffice, which is an open source version of Microsoft Office. And I included this one because it really highlights, it's what showed me what we were running into. So if you look at on the right-hand side, that text import window, and you look between the zip code and the latitude value, you can see an arrow that's kind of pointing down and to the left. And so this was the first software package that actually gave us a visual representation of the embedded carriage return that was causing all those weird formatting things that we were running into. So I include all those slides to basically say, depending on which software package you're using, they're going to handle this carriage return in different ways. So you got to be kind of familiar with how these different programs will deal with kind of pseudo-invisible carriage returns. So what we decided to do was, before we brought the CSV into any particular software package, we were going to do some data processing in Python. And the goal was really to pull apart the full address field into its individual components. We wanted to isolate the address from the latitude value and the longitude value. We wanted to be able to use the lat-long coordinates, display X, Y, and get a set of points. We could have gone with the geocoding route, but that presents its own set of problems, and X, Y is, I think, more reliable if you can get the data in the format you want it in. So once we had decided to go that route, the first issue we ran into was that there's no consistency in this field. So there was no consistent number of characters, or there was no consistent number of spaces. So we couldn't say something like, go 30 characters, start here, and do something. We couldn't say, go 5 spaces, start there, and do something. There, some addresses have prefixes, some have suffixes, so there was no consistent way we could do that. Our approach ended up being to try to isolate some unique characters that are in the Latin long coordinates and then move from there. So we thought, it looks like the latitude value has the first period in that cell, and that the longitude value had the first dash. And if we could isolate those locations and then move back or forward a couple spaces and grab that text, we could write that out to its own row. Once we decided to go that route, the first issue we ran into was that sometimes the period isn't the first, the period in the latitude value isn't the first period in the column. And so for those cases, we basically came up with a find and replace, and it just goes in and searches for that and overwrites it. It removes the unwanted character. And then the second issue we ran into was that sometimes the latitude and longitude values were backwards. And that's what's happening there at in the very bottom, the little section highlighted in blue. The longitude value in that case came first, and so obviously our points weren't where we expected them to be. And so for that, we came up with an if-then statement. And basically, we go in and we find the location of the point and the location of the dash, and we compare them. And if the point comes first, we process the data in one way. And if the dash comes first, we process the data in another way. So to kind of recap what we do in Python to process the data, we wound up with a series of 3 scripts. The first one just removes the header and the field names because they weren't very useful. The second one has the find and replace that goes through and removes any of those unwanted characters. And then the third one actually breaks apart that full address field into its individual components. And then it can write everything out to a new CSV where each individual column is a unique data point. So then we have a clean CSV that we can import into SQL, and everything works the way we want it to. So that's what I've done here. At this point, I'm importing everything as a text field. It's just to maintain any formatting, make sure we don't lose any data. And then there's some intermediary steps where I assign field types. And so, as I said at the beginning, one of the things that the fire chief was interested in was being able to analyze his fire-related call response. He wanted to know the areas in the fire district where they weren't able to make it to a call in a reasonable amount of time. And so, while there were time fields in the data, there was not a response time field, so that was something we had to calculate. And that's what I'm doing there in that first little block of code. I'm taking the time when the call came in and subtracting it from the time when the unit arrived on scene to get the response time. And then I'm converting that into a couple different field types. The middle block of code there is just setting it as a text field. And that's really just for legibility purposes for the end user. It displays the best in the dashboard and in ArcGIS desktop and in the web app. And then the last one is converting it to decimal time. And that's what is used in the calculations and the queries that are built into the dashboard and into the web application. So once we've done all that processing, we're ready to take all those incidents and then append them into an incidents total table that has all the incidents from the previous times we've run this job. And once we do that, we can then take that table and feed it into a model that creates an XY event layer, spits out a feature class in our SDE geodatabase that the web services are built off of. And then those are consumed in the dashboard and the web app. And the only thing that we still have to do manually in this whole process is actually download that CSV. So after we download the CSV, we can just put it in a certain location on their server, and then the job will run automatically, and the rest happens by itself. And so this is what the dashboard looks like. Let me see if I can actually bring it up. There we go. So can't actually control it though. So First thing I'll point out is up here in the header, if you're only looking for a specific year, you can click that. I think that should be 2017. Is that right? I can't really see it. And so all the other elements in the dashboard will work off of whatever you click. So if you're only interested in fire calls, come in and click that. You can see that in that year there were 142 of them, an awful lot in February, I think. And during that month, they averaged a little over 15 and a half minutes per call in order to get to the scene. So it's a real brief, highlighting of the dashboard, but like I said at the beginning, most of this project was really the data processing in order to be able to use the dashboard. So that pretty much wraps it up. I'll open it up to any questions. Right now, we're only doing it monthly, but it's kind of up to the client however often they want it to be updated. So, like I said, the only part we have to do is download that CSV. The rest of it can run automatically. So, as often as they want to upload that CSV.
So they'll give you the standard URL for that zip file?
No. Yeah. It would be nice to have the whole thing automated. That's sort of the last step, but. Yeah.
Does the map extend filter the rest of the graphs? What's visible on them? So you zoom in on the map?
Yes. Yeah. So each element is dependent on the other. So if you zoom in, yes, everything in the others would change as well.
You briefly mentioned connect to KMA data, and so do you have the KMA data?
So that was separate from this project. That's something that we do as a business a lot, but that's not what this project was about.
Did you guys consider using regular expressions to kind of find the type of things that you're looking for with the last one?
That I'm not sure what you're asking, I guess.
I'm not super familiar with it, but it's built into Python and other languages. It's just patterns. You probably know better than I. But it's a way to. There's a lot of special ways you can search for types of text, and if this type of thing comes before this, or these characters are like this, it's a whole kind of extra sub-language that.
Okay. I mean, I'm not a Python expert. This was sort of this was my first foray really into it. So
It would be very difficult to come up with pattern data you showed me there to be able to use for again. You were talking about switching the lat longs and everything else.
right.
That's really good for standardized patterns.
That's built on a map service?
Yes, it is.
One
Yes.
for you to do?
Once you have the map service, the dashboard itself is really easy. I mean, that one would take you like 20 minutes to set up, maybe. You do have to have a web map that feeds the dashboard, but. Okay, thank you.